Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Today, Min Walker. She's currently head of the Cognitive Systems Group at University of Sheffield. Many of you are probably familiar with her extensive work. She's done great work on language generation, spoken dialogue systems especially. She was heavily involved in the Communicator project, and many people know of the Paradise evaluation framework. She's very widely cited, and it's our honor to have her here today. So, the title of her talk is Statistical Spoken Language Generation from Stylistic Generation.
Hi. Thank you. This is probably some of the stuff I don't need to go through for this audience. I want to start off before I kind of start launching through this. Well, I'm trying to do something a little. I've never given this exact talk before, and what I'm trying to do here is I'm trying to pull out a thread from like 8 years worth of work, and talk about 3 different generators that we developed where each thing gets successively more difficult. And because I've never given this talk before, it's not maybe as streamlined as I would like. And I do have too much material, but a lot of the stuff what I want to achieve maybe is to get to the end of my talk and and at least make sure that you can see the relationship between the stuff that we've been doing on the personality generation and the kind of early stuff we did for AT&T Communicator, and that we've kind of followed this same thread through and made the problem more and more complex as we went along, and that the thing that we're trying to do now with the personality generation is much, much more challenging than what we were trying to do with that original problem. So that's kind of what I'm trying to do, and some of the stuff that's in the middle here, that's like the chronological sequencing of stuff that we did kind of on the way to get to this more complex thing, I might kind of buzz through, but that's not the main thing that I'm trying to do with the talk. I'm just trying to show that there's this thread where the problem gets a bit harder, bit by bit. Okay. So, so this is a kind of standard dialogue systems architecture, which I'm sure you're all very familiar with, where you have speech in, and then you get some spoken language understanding. You have a dialogue manager that takes meaning from the understander and decides what to do, and then it would pass some kind of communicative goal onto a spoken language generator, which produces some words, possibly marked up to go to text-to-speech synthesizer. You have that output, and you can put, you can make it multimodal by putting gesture stuff on this side, or putting an animated agent on that side. And the problem that we've been working on is that for a lot of these components, namely ASR and TTS and some parts of spoken language understanding, this has all been data-driven, and statistical methods have been used for some years. But there's been less stuff in this area, and you still have the situation where in commercial systems, this stuff is all completely handcrafted to the point where a lot of times it's just pre-recorded prompts here, and this is highly, highly tuned. And so what I started off working on at AT&T was trying to look at, well, how can we open this stuff up a little bit and make it more procedural, make it automatically generated, automatically trainable, so that we can roll out 100 new applications in a year and not have to have this whole design cycle where we're just kind of going over it and over it and over it again, trying to get it better. And so the argument that I'm trying to make is that if you pull out the language generation from the dialogue management, so instead of having just a little prompt server in your dialogue manager, if you actually pull out generation component and you actually use some of the ideas from the natural language generation community, that you can get higher quality system output with a lot less handcrafting, that it should give you portability and customizability for different domains, applications, and user groups. If you move to these trainable methods, you can get personalization and stylistic variance, and this personality generation is kind of the extreme of that. You get that as a kind of freebie from using these kinds of methods, where it would be impossible using a handcrafted method to have a system that produced customized prompts for an individual user based on some user attributes like their personality preferences. And I'm going to, I'm still interested in the possibility that some of this stuff is important for task-oriented dialogues. I'm going to talk about the DARPA Communicator flight booking application. But I'd really like to look with some of this linguistic variation, how we could use it in some kind of training and learning or educational applications. And a lot of the work in the gaming community on interactive drama systems, they're finding out the same thing, that there's an authorability problem, that this stuff is all highly handcrafted, and you have these very simple dialogue trees, and you don't have really very much interaction. And it's a lot of the same problems that the spoken dialogue community has already recognized and been working on for 10 or 15 years. So, there's a little, sorry, that happened in some kind of trance. Anyway, that supposed to say content planner, sentence planner, surface realizer. So what we did was we took this kind of natural language generation architecture that pulls out these different components of sentence planning, surface realization, and prosody assignment, and along with the content planner, and we've kind of embedded that into a dialogue architecture. So the spoken language generator kind of explodes into this stuff. Content planning can either kind of be part of spoken language generation, or you can have that be part of the dialogue manager. This kind of thing, it kind of sits in between. And these different components, so the content planner decides what information must be communicated, and it might do some work on selecting the content and ordering the content. The sentence planner decides what words and syntactic constructions will be used for describing the content. And two of the things that go on in sentence planning that I'm going to talk about a bunch in this talk are aggregation, which decides that given some content that you want to express, how should you group that content together into sentences or phrases, and how should you order it and spread it apart, and what lexical items should you use to express the various entities. And lexicalization is one place where you can get some very interesting stylistic variation just with word choice amongst different synonyms. For the realizer decides how, given a particular sentence plan, how it's all combined into a sentence that's syntactically and morphologically correct. And we use an off-the-shelf dependency tree-based surface realizer. And then you have this prosody assignment module, which is, there's been quite a bit of work on how this component can be trained as well. So I'm going to talk about these three generators. Like I said, I'm trying to pull this thread through. So we started off looking at the statistical generation work in the SPOT system for DARPA Communicator. And we were interested in the information gathering phase of the dialogue, where you're trying to elicit information from the user about where they want to travel to and what they want to do. And the paradigm that we looked at for statistical generation is this overgenerate and rank paradigm, which had been previously used for machine translation, or it's kind of normally used for speech recognition. And the idea is you just take off a few of the top ones and then pass those on to the text-to-speech engine. And the next thing that we did was we looked at information presentation in this match multimodal dialogue system for restaurant information. Information presentation is more complex than information gathering. You have rhetorical structure, you have these persuasive goals, so you have content that is in service of other content. And so that's a kind of next layer. And that we also use this overgenerate and rank paradigm there, and you also, in that case, you wanted to kind of pick off the end best. But one of the other things that we added in there was we looked at whether we could train these for individuals. So we have results for training for individual users. And then this stuff that I've been doing over the last 4 years with my student, Francois Morse, is to kind of pull through that thread and look at generation of lots and lots of stylistic variations based on the Big Five model of personality. And again, we've just built on this same underlying structure that we had in Sparky, where you're doing information presentation in the restaurant domain to make recommendations and comparisons among restaurants. So we have that same structure, but we have something completely different here, which means that the overgenerate and rank model doesn't work for us very well anymore. So these personality traits are, there's 5 of them. There's scalar targets like neuroticism, conscientiousness, agreeableness. They each have linguistic reflexes that kind of display that personality. And what we're trying to do is to generate an utterance to realize a communicative goal that can simultaneously express all 5 of those personality dimensions. And so it's a much more challenging problem. Instead of just trying to pick off a few top things, we're trying to hit particular targets across this whole scale. And yeah?
So when you talk about generation, is this focused mostly on like spoken language generation, or do you take into account like gestures and like
no, just the spoken.
Just the spoken.
Yeah.
And like I wonder, is there an understanding like of how much of those personality traits can be expressed,
There's stuff in psycholinguistic literature
that tell you all that.
that will tell you all that, exactly. So there's a lot of stuff there that we would like to be able to use. There's stuff on, we don't have a text-to-speech engine, which is one of the things, that we don't have a text-to-speech engine that lets us get the prosody variation that we might want to get to, say, distinguish introverts from extroverts. We could, we could use we could use old-style synthesis where you have all the knobs, but then you don't, right? So anyway, so that's kind of, that's, like I said, I'm trying to talk about all these things. So I'm having a problem with my slide. The top of it's getting clipped there. Hopefully this won't happen too many times. Anyway, so this first system is this SPOT system, which is work that I did with Owen Rambo and Monica Rogati. And the motivation for introducing spoken language into DARPA Communicator was this big thing with DARPA Communicator, that it was supposed to be a mixed initiative dialogue system. So that instead of having a system initiative where the user had to answer each question with a single piece of information and you build up the information, the idea is that you could give the system information that it didn't ask for, and you could answer the questions in any order you wanted, and you could provide lots of information in a single turn, like that. And what most of the people in the program were really focused on was that, that meant that the speech recognizer had to be able to handle a really wide range of inputs. And they figured, the dialogue manager had to be capable of tracking and accommodating the user initiative. But the point that we were making was that it puts a lot more demands on the output, because there's all these different combinations of communicative goals that you don't get when you have a system initiative system. And let me show you. So for like template-based generation, like if you were just trying to, in a system initiative system, you can get along with template-based generation like this. Say you want to produce an utterance like that, meeting those goals, then you can have some templates for confirm the destination, confirm the date, and then you can have a single question like that for what was your departure airport, that's indexed by that's the second time you've asked for that piece of information, so you have a particular form. And the reason why people use these methods is because they're really they're conceptually simple. You don't really have to understand very much about structure of language to build a system that way. The disadvantages are that you ended up repeatedly encoding these linguistic rules. You'd have to do this afresh for every single domain. And if you want to do anything kind of interesting, like we looked at the CMU corpus for the human travel agent, and we wanted to model that human travel agent's behavior with cue words. Like she'd start utterances with and or now. There was lots and lots of stuff in there that we wanted to be able to do, but we couldn't do it in this framework because we couldn't then just concatenate a bunch of templates together, because the cue words would all be kind of out of place. There was no way, there was no way to do that, and we couldn't really get interesting variation. And so if you wanted to get the interesting variation, what you would have had to have done is you would have had to have a template that corresponded to, for every communicative goal, you would have had to have a template that corresponded to where in the linear order that template was going to appear and what other communicative goals. So you end up with a power set of templates for every communicative goal in order to do that. And so we said, well, when you start getting into this situation, it really starts to make sense that you would have something that was more procedurally based, that was generating things dynamically rather than just having these stored forms that you're indexing into. Now, the particular generation task that we focused on was this sentence planning task, which it takes a set of speech acts from the dialogue manager or the content planner, and it maps those to syntactic structures. And so for some kind of collection of communicative goals, like confirm the departure, confirm the destination, confirm the month, confirm the date, and then ask for the time, you can get hundreds and hundreds of possible realizations. That's what the sentence planner does. It decides the linear order, how many things go into the same sentence, and so you can get a single sentence that combines everything all into the same sentence, does all the confirmations in one thing, or you can get this maximally redundant one where each communicative goal has a single phrase associated with it, or you can get these kind of different combinations. And so we kind of, as I said in the beginning, we built on this work like in speech recognition and Irene Lankilde-Geardy's work that was used for translation to kind of split sentence planning into two parts, where we have a sentence plan generator that stochastically generates a wide range of sentence plans to achieve a particular goal, and then we have a ranker that's trainable. And we used these high-level linguistic features to represent the sentence plans, and we used rank boost, which is a form of boosting, to learn the ranking rules. And so this is just repeating kind of what I said before. So the dialogue system would give a text plan or a content plan to the sentence planner. You go through this overgeneration phase of the sentence plan generator, which generates lots and lots of different possibilities. And then you have this trained ranker, which passes one or more things onto the realizer. And another thing that this lets you do, I'm sure that some of you are familiar with the work that I can't pronounce his name, Bulyko did with Murray Ostendorf on kind of joint optimization of the text-to-speech engine with the generator. And they showed that if you have, like current style text-to-speech engines, you're going to end up with holes in the text-to-speech database, which you can't predict where those holes are going to be. And so if you have a kind of architecture where you can produce multiple outputs like this, you can end up with better output overall by just producing a rephrasing of something that doesn't happen to hit one of those holes in the text-to-speech engine. So, so first this same kind of basic architecture I use all the way through. The basic idea is that you have an overgeneration, or you might have something like an overgeneration phase at some point in the process, and then you have a training phase. So in the sentence plan generator, you have a dictionary lookup where you have each elementary speech act is associated with one or more syntactic structures. And then you have this set of operations that can combine the syntactic structures into larger syntactic structures. And these operations are selected randomly according to some hand-designed probability distribution, which could be learned from a corpus. And it produces a sentence plan tree which represents choices of different ways to say things where the nodes are operations and each node is associated with a syntactic structure. So the combination operations that we had for SPOT, for this information gathering thing, were ones like these, like merge, which aggregates two propositions, like you're leaving from Newark, you're leaving at 5, and it could produce a dependency tree. So take the dependency trees. I'm using the strings as representations, but I'm really talking about operations on dependency trees. And it could produce your leaving at 5 from Newark, or relative clause, for example, your flight leaves at 5, your flight arrives at 9, and you can get your flight, which leaves at 5, arrives at 9, or an adjective operation. your flight leaves at 5, it's a nonstop flight, your nonstop flight leaves at 5. So those, we had all these different operations for aggregating information. And this is an example of one particular form that we could produce. And this is what the sentence plan tree would look like. So that you have the speech acts on the leaves, request, implicit confirmation of the destination, the origin, the day, and the month. And then you have the sentence planning operations on the nodes. And there's a parallel structure behind this where each speech act has a dependency tree. And when this merge operation applies, it combines the dependencies and produces a new dependency tree, which could be sent off to the realizer. So you build this tree, and then you peel these things off and send them to the realizer to produce the utterance. And that shows what it's like. So we have this dependency tree at the top there that represents the combination of all those goals. So there's this overgeneration phase here where the sentence plan generator will generate a random sample of possible ways to realize a set of different communicative goals. And in this case, so we asked 2 judges, expert judges, to rate each variant on a scale of 1 to 5 as to how good of a realization it was. So this is the idea is that you have a small sample and that it's going to be big enough that you can generalize, to unseen cases. And then we have a feature discovery process that runs over these tree representations, discovers features that encode the decisions that were taken in those trees, like which operations were used, and it throws away any features that don't occur, at least 10 times. Then you apply this rank boost algorithm to learn the rules, and you can test it with 5-fold cross-validation. And like I said, the features are discovered by running over these trees, and they look like things like that. Like there's an ancestors feature, which says that that an ancestor of a merge, what does it say? That period is an ancestor of a merge operation, or that in the dependency tree that the word travel is an ancestor of the word like. Or you have these sisters features which say that inside a sentence plan tree, there's 2 nodes that are siblings that are both implicit confirmations. And these can be kind of more or less general. So that you can just represent that they're implicit confirmations or that they're implicit confirmations of particular information. The rank boost is, as I said, it's a form of boosting. And the basic idea with this is that you represent each example. Each feature basically has a function associated with it. So that's this indicator function h says hs of an example is 1 if a particular feature count is greater than 1. Otherwise, it's 0. So each of these functions, it's associated with a single parameter. And the ranking score is just it's the weighted sum of those functions with their parameters. And the score is used to rank competing sentence plan trees for the same text plan. So the training data, one of the things that's nice about the rank boost algorithm, I think it's nice, some other people might think it's excessive, is that what it does is if you have a partial order of examples that you have ratings for, that the training data is the set of pairs for every single pair in the example. So it really makes a lot of use of the data. It doesn't just doesn't represent that A is better than B, but it represents that A is better than B, and A is better than C, and A is better than D. So it makes a lot of use of the data. The training process is to set the parameters alpha to minimize the loss function, where the loss function is ends up basically being the count of correctly ranked pairs over the total number of pairs. And as you minimize the loss function, the f of x minus f of y, where x is preferred to y, this is a remnant of a different representation of the loss function. Basically, you minimize the loss function, you get fewer and fewer pairs that are out of order. And one way to think of the rank boost algorithm is it's kind of like bubble sort. Like if you have a bubble list and you're trying to get it in order, it's just counting how many flips you have to make to get the thing back to where it should be in the partial order. So this is one evaluation. This is just an evaluation on the original expert labeled data. And so we compare the trained sentence plan ranker, which is SPOT. We compare that with randomly ranking versus a human oracle, which is BEST. So you can see that when we produce this random sample, we have something like a normal distribution. And so when we sample from that randomly for, to try to get the right thing for a particular text plan, we end up again with something like a normal distribution. But what we're trying to do is we're trying to pick this stuff that's up in the high end of this distribution. We're trying to get 2 or 3 things that are up here in the top. Didn't we do emit background from that slide?
No, we did.
Okay. Anyway, the bottom line here is that SPOT is much, much better than random, and I think it's a little bit worse than BEST. And we also did a more large-scale human evaluation of this with 60 human subjects, where we also compared to a bunch of different baselines, like a fully redundant baseline and things like that, and to the template-based generator that was originally part of the ATT Communicator, and we were able to show that SPOT, with this small sample of training data, did perform as well as the template-based generator, which had been tuned to the system over a couple years in the DARPA Communication competition. So the kind of rules that it learns, and just for people that aren't familiar with Rank Boost, the kind of rules that it learns are things like if a particular feature count is greater than 1, then increase the ranking of the example by some alpha, right? That's what it learns. And so it's for the end of that bit of that project, as I said, we evaluated also a large-scale human evaluation against the template-based generator and several other baselines, like a no aggregation baseline, and we showed that it was as good or better, and we argued that it was would be less effort than the tuning involved. And we integrated this, we had a version of AT&T Communicator, which was not ever tested in the DARPA test, but it was still, we had it in there, so it was fully integrated. So we were able to fully integrate it into the system. Yeah?
With respect to the templates, were they also made by experts as well? I mean, because you would think that if the...
Yeah, so it would have been like Susan Boyce, Dawn Dutton,
Okay, and
right?
they're also the same people that are rating on a scale of 1 to 5 the different generalizations that you use to train the model.
Didn't...
So when you were training, as part of your training data, you had all of these realizations, and you had the experts rank the realizations on a scale, right? Presumably, they're using some, let's say, internal representation in their mind of what is a good realization. Presumably, shouldn't it be the case that if they're also making the templates would reflect,
Well, they weren't the
criteria.
same people. Yeah. And besides, in that case, in the Sparky stuff that I'm going to talk about, so in that case, the template-based evaluation was with our 60 naive subjects, right? So that the template-based comparison was with our 60 naive subjects who were just like, man on the street kind of thing to say which one was better, right? And the experts who did the ratings that we used for the original training data were not the same people that had designed.
I'm just trying to tease apart, like, if the system that you're building is really trying to get at what the experts are using, and if it's the same people that are making the templates, then you would expect sort of like a closer performance.
Yeah, but the thing is that the template, you're kind of hamstrung by the technology of what you can do. That's kind of the whole point. You're kind of, no matter how good of an interface designer you are, if that's your model, that you've got a bunch of templates and you're going to concatenate them together to produce the utterance, there's just only so much you can do, right? Unless, because you're not going to have this really complex context-based indexing into all these different templates that's going to allow you to get something really high quality. You could do it in principle, right? You can do anything, you know, but you just don't with that technology. It just blows up on you, you know. So, yeah?
So does that mean that you use pre-recorded prompts that were, you know, shuffled together one way or the other, or you use TTS as the output?
In our stuff,
Yeah.
TTS.
For all of them?
Well, we didn't. In the evaluation, we just did a text-based evaluation. In the system, in both systems, it was a text-to-speech output.
The evaluation was text only, so they...
In this evaluation, this one, that one was...
The previous one where you show some bars.
Yeah, that was text only.
Okay. Because
That's just comparing the rankings to the rankings.
to show this with a complete voice output, you know,
Yeah.
something that might be more rigid, maybe not as good from the text point of view, because it's a nice prompt and it sounds good.
It might
be
sound better.
preferable than something that from the text point of view might be better, but because it's TTS, it's
Right, that's...
an additional question that, you know, system builders have.
And people subsequent to us have actually done that, like Crystal Nakutsu and Mike White had a paper at ACL 2006 where they applied this method, kind of like the stuff that Mari did with Ivan Blico or whatever. Yeah. But Mari's stuff, they did that with they hard-coded like 3 possible ways to say something, I believe. And they, just to show, just as a proof of concept, that if you had multiple ways to say things and you could select them intelligently, you could get better output when you kind of combined the optimization with the text-to-speech and the selection of which template to use. And then Nakutsu and White had a CCG-based generator, so they had a generative generator like the one that we're using. And they did a thing where they showed that they could get better sound, you know, better sounding utterances by using this method, but we didn't do the sound. This was, we just were focused on, you know, the kind of the method and what could we do with it at the text level, with the assumption that the next step would be to look at the sound. So this next thing with the Sparky is a kind of, I said a lot of this, it provides the basis for what we did with the personage, with the personality generation. The first thing that's the same is that we looked at information presentation, which involves this rhetorical structure. And then, as I said, what we claimed with the spot work is that when you move to those trainable methods, if it was based on feedback from humans, it opened up the possibility that you could do these individual preferences, that you could train for a single individual. But we didn't actually do those experiments in the spot domain. And I'm not sure if it would have shown up so well in there because there's just not as much going on in the information gathering that people can have preferences about. But in information presentation, there's a lot more structure and there's a lot more different things going on. So we did this in the context of this multimodal restaurant information system that we had that we wanted to put it on an iPack. But at the time, all the underlying software to run this kind of stuff on an iPack was in big flux. And so we did this on a Fujitsu tablet with the idea that like the next generation would be a little smaller handheld like some of the stuff you've been showing me this morning. And so we had touch input and speech, and then we had pen input on this as well. And this is work. This is a system that Michael Johnston's kind of spearheaded the development of this system, and we just worked on the language generation. So in this case, instead of having that set of speech acts like we had in the for information gathering, where there's kind of no structure between them, when you start looking at information presentation, you have these utterances that have rhetorical structure. So for example, for a recommendation, you have these rhetorical relations between content items that you also want to try to communicate if you can. So we kind of, our model of this content planning is this kind of bottom-up model based on Daniel Marcu's work, where you have some content that you have to communicate this content. You have these rhetorical relations that you want to communicate if you can. And basically what this says is that the nucleus, the main goal of the utterance, is to assert that Babbo is the best restaurant, and that these satellites, 2, 3, and 4, are kind of supporting evidence that are related by this justification relation to the nucleus. So this one says that, Babbo has superb food quality, it has excellent decor, and it has excellent service. And just like in the information gathering, these would be in a generation dictionary, not for the individual restaurant or for the individual value of the attribute, but you would have some syntactic representations in a dictionary where you could look up the mapping between this domain semantics and the utterance. And so Sparky is basically, it's a very small extension of Spot. Again, we have this SPG that stochastically generates sentence plans, and we have the trainable sentence plan ranker. Again, we're using sentence plans represented by features of tree structures, and we used rank boost. Only this time, we have these, these additional constraints on when these rules, these combination operations can get applied, is that they only get applied when the node has been decorated with a particular rhetorical relation. So we still have this many-to-one mapping between the meaning and the ways that you can say it, but we have this extra constraint of the rhetorical relation that holds between two arguments. So again, we still have like a merge operation that can combine two things, but we also have stuff like justify, Amy's bread has the best quality, its price is $12, it has decent service, and then you put the since in there to link those two things together. So the main new thing here, besides a different domain and these kind of more complex operations, was to look at this individualization. And the idea is that, well, humans do this, they adapt to one another in conversation, they use each other's syntax, they use each other's lexical terms. If we had a system that could do this, it might help reduce cognitive load, it could increase the perception of being in rapport with the system or being in sync. And so we decided to look at this individual adaptation, and we had something, like I said, this is very similar. We would have these tree structures for the sentence plan trees, and these get mapped into features through a feature discovery process. And we have two users. In this case, we're looking at two users. They see a bunch of possible ways to say something, or they hear it. I honestly can't remember if there was a little button there where they could hear them or not. And they would give a ranking. And one of the things that we noticed, that we'd also noticed with the Spot data, is that people did not agree necessarily on what was the best way to say something. But there had been this kind of implicit assumption in the generation community that if you could do a good enough job on the handcrafting, that there would be one single way. But when we started collecting this data like this, we found very quickly that there were big differences. And if you compare two vectors of two people's judgments, they're never the same. So like I said, rank boost produces these same kind of rules. I don't have to go through that again. Can you see this? So this is the ranking loss, which is the percentage of correctly ranked pairs. And this is trying to show the benefits of the individualization. So a random model gets about 0.5 ranking loss. And so if you have A's model with B's test data, you're doing as bad as random. And if the same thing is if you have B's model with A's test data, you do as bad as random. This is missing this third column here, which is if you train the average model and you have the average model data, you get something like 0.20 here. So even when the model is fit to the average user, you're not getting as good of a fit. And I think it's because there's just more noise in the data because you've got these judgments from these two users which aren't really agreeing about which things are good. And you get these really nice fits when you do this individualization. So that was one of the main things there. We also did a qualitative analysis with it, which I was really interested in because it's a machine learning method. I wanted to be able to say, this isn't just a random overfitting of these models to this particular user, but that these things kind of make sense, right? That some users, want things one way and some users might want them another way. So some of the things that we found between these two models, and I'm not going to spend very much time on this, I'm going to kind of skip through it, but there were things that in the literature on, for example, argumentation structure that were kind of unclear. Like the literature says things like, oh, the claim should be first, unless you think that it's going to be really hard to convince this user, in which case you should put the claim last. Or put negative content in the middle, unless you think that the user already strongly believes the negative content, and then in that case put the negative content first. And so there's all these kind of things. If you look at popular science books like How to Write a Good Argument, or things like that, there's all these contradictory guidelines about how to do this. And so some of those things that we actually saw in these differences between user A and user B, like one of the users liked to have the claim first and the other one liked the claim last. There were particular keywords that some of the users, one user liked that the other one didn't like. One user liked longer sentences, one user liked shorter sentences. And we argued that, even though this is kind of proof of concept and we didn't do it for 60 users and do this qualitative analysis, that the results were meaningful to show that there really were differences and it wasn't just, something that was an artifact of the training method. Yeah?
Why is this? Online, if you are talking to someone, and how can you get their feedback about which way they prefer? The application of this type of technology.
Well, one idea would be, if you have an enrollment phase for a system, you could ask people for. There's a lot of different things you could do. You could have, you could look at the person's own syntax, and you could ask people to upload a bunch of their emails or a bunch of their documents, and you could extract some parameters from that you were trying to match. You could ask people to go through an enrollment phase with the system where they gave some judgment. So one of the things that we looked at, and we didn't try to do anything really, really smart with making really good use of data. So we didn't do active learning, for example, which might, if you were doing something like that, you might be able to get the number way down. But we did look at, in the paper, in the journal article that just came out in JAIR for this stuff, there's a plot in there that shows that I think our training data had 600 utterances or something like that. But by the time you'd seen 120, you had got you'd learned most of what you got. The ranking error was down to 0.2 or something like that, and then you were in the tail there. So the steep part of the curve was up to 120 utterances, and I'm saying we weren't trying to do anything very smart. So that's okay. So I'm not going to go. I already said most of that. And then this is your question, right? So, can you learn it in real time? Is there some kind of aspect of the user's feedback? You could drive it off of something besides the user's ratings, like if you had some measure of cognitive load or misunderstanding, some kind of implicit feedback based on what they did, like whether they asked for the thing to be repeated or some, there's lots of different kinds of things you could do. So basically this method requires some kind of scalar feedback on utterance quality, and you might be able to get that from someplace else besides an explicit ranking from the user. So
the user actually got to put in their own reviews, you could use that. So you might,
you could match.
Right. So the user might put, well, this has good food, blah, 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 blah. And then that way they're also contributing to the community while at the same time you're actually learning
explain it.
Yeah, and one of the things that I didn't talk about that we just did, that Nakutsu and White paper that was in ACL 2006, we were writing this stuff up for publication in a journal at that point, and we'd never tried n-gram features because we had all these high-level linguistic features, and we thought, why, it's got to be, we have all these things that say like this structure and, all this kind of stuff. And so we did it with n-grams, and the n-grams perform really well. So you could, for the corpus, one of the reasons why we think it performed well is because particular words tend to be highly correlated with the particular operations. But it might work, it might work quite well, the same, just using n-grams just by themselves without having that definite match. So that, like you said, you could analyze the user's reviews, and then you could do some kind of style matching on their reviews when you generate reviews for them. So this is the last part of this thread where we've kind of really blown this up into a lot bigger thing that we're doing, where we're using these big 5 personality traits, which each have scalar values, and each of these scalars are normally distributed in humans. So instead of trying to pick the top end of that normal distribution that our random generator is making, we're trying to still, well, I'll show you, okay? So the big 5 personality traits has become a standard in psychology. And the traits are neuroticism, openness to experience, agreeableness, conscientiousness, and extroversion. And this has become a norm in psychology pretty much about over the last 50 years. And the way that these traits were derived is by a factor analysis of trait adjectives. So the first person to do this was Allport in 1939. He took something like 14,000 English words that are used to describe people, and he asked people to describe themselves and describe others, and then he looks at which trait adjectives tend to cluster together into factors. And anyway, so after repeated psychology attempts to kind of duplicate this, there's a kind of general agreement in the field that there's these 5 dimensions. Some models have 3 dimensions. Some of the 5-dimensional models are hierarchical, so you have little subdimensions in these personality traits. But these are the kind of trait adjectives that would be associated with it. So the extrovert, and each of these, as I said, they have a low end of the scale and a high end of the scale. So each of those corresponds to, a whole scale. So on the low end, you'd have quietness, reserve, solitary. And on the high end, for extroversion, you have sociability and assertiveness. Emotional stability, you have calmness versus neuroticism or anxiety. Agreeableness, you have kindness versus unfriendliness. Conscientiousness is, orientation to duty, need for achievement, being highly organized versus being impulsive. And openness to experience is kind of imagination, intelligence, and insight versus conventionality, rigidity. And there's strong suggestion that at least for extroversion, emotional stability, and some aspects of kind of agreeableness, that they're highly linked to biology. So like extroversion is linked to the dopamine receptors in your brain. So personality psychologists have kind of looked at the effect of caffeine on extroversion. And there's all this stuff that, if you look at identical twins, the correlation for identical twins for the extroversion measurements are 0.5, and for siblings it's only 0.2. So there, extroversion is dopamine, emotional stability is linked to serotonin, and agreeableness is linked to testosterone. You won't be surprised about that. So the idea with this, going back to this original architecture where we have spoken language generator, is we want to see, well, what if we can put some personality information into there from somewhere, right? And the question is, well, why would we want to do this anyway? And I mean, the one bottom line is that any system that generates textual spoken output, it has a personality, whether you design it in or not. So it's something that you might want to be aware of when you're kind of designing. But there is lots of stuff that suggests that, people's, that it has strong effects on users' perceptions of system competence. So there's some stuff that was done in the Reeves and Nass group at Stanford that suggests that people's perception of things like how intelligent something is has nothing to do with the actual personality variables that they were manipulating, but that perceptions of intelligence or competence at the task and things like that are strongly affected by personality. Also in the real estate domain, Bickmore and Cassell showed that extroverts preferred an embodied conversational agent that engaged in a little bit of social chit-chat around the task-oriented dialogue. There's some work done that shows that politeness, which is an aspect of agreeableness, so polite is one of the trait adjectives associated with the agreeableness trait, that it actually improves learning outcomes, and especially, if you have anxious students or students with low motivation, linguistic style can have a big effect on their performance. So, so we think that there's a lot of reasons to do this from a systems side, and then of course there's your kind of good old-fashioned AI cognitive science interests, like do these findings in personality psychology, can they be computationally modeled? Are they useful? Do they transfer across domains? And most of the work that's been done in this area, people have done stuff with this, but nobody's really evaluated it to see whether they can actually make a manipulation that really affects people's perception in the way that you would predict from the psychology literature. So Tim really wanted me to. Now, this will be a challenge. There. Okay, so this is just an example of some data that we use for personality recognition. We've also used this to do some out-of-domain ranking models, but I'm not going to talk about that today. But this is just to kind of give you a flavor of some of the kind of classic differences, say, between introverts and extroverts. So this is from some data that Matthias Mail at University of Arizona collected. EAR stands for electronically activated recorder, and he got 100 undergraduates to agree to walk around being mic'd all the time for 2 days, and this recorder would start up and sample snippets of their talk, and they had all done a self-report for personality. Then he had 7 observers listen to these snippets, to the 48 hours worth of snippets, and mark these up from an observer's perspective about what personality these students were exhibiting. So it's a really nice data source, and it's kind of one of a kind.
Is there a lot of self-assessment?
I'm pretty sure that the agreement was pretty high. The thing that I remember most strongly is that the observer agreement was quite high. Much higher than, so amongst the 7, yeah, I can't remember what the number, because we're interested in the observer number because we compare that to our own observer judges with the stuff that we're generating, right? And our observer judges number is as good as these numbers, that he has for his observers. But I think that I'm pretty sure that he shows that there is a strong relationship between them. But other work has suggested that certain traits, there'll be more correlation than others. Like neuroticism is not a desirable trait. So, so you don't...
Yourself as a neurotic person.
Well, you might be willing to let that come out. You might be willing to answer a survey to say, oh yeah, I worry about things, or I always think somebody's trying to steal my ideas, or whatever, But maybe when in public, you don't let that out, right? And so you have a persona that you're kind of presenting, and you don't let on. But the idea with this data was it's supposed to have a lot of ecological validity, because they're kind of supposed to forget that they've got this thing on, and they're just walking around and doing what they're doing, right? And so, so this is the introvert
giving you a hard time, so. But,
Oh, he maybe turned it up.
I'll go check my email soon, okay? I said I'll try to check my email soon, okay? Did you guys?
So that's a kind of some of the things that have been noted in the literature is that introverts tend to have lower amplitude. They tend to speak more slowly. They have a more compressed pitch range. They use more first-person pronouns. They, right? So there's all that. They don't take the initiative in conversation as much. And then this is this little extrovert.
This is happening to me a lot lately. My phone will ring, and one thing it is, it'll say call. I'm waiting for nobody will say anything. So I don't know who it is. Okay, I don't mind when someone's a little sad.
Okay. So this, so that, you notice like she talks louder, it's more bouncy. And I mean, there are gender differences as well, but she talks louder, it's more bouncy. There's much longer utterances. She takes a much bigger turn. Extroverts, they have a big need to talk, so they're very redundant. She's, paraphrasing herself, right? She's just, kind of filling up the talking space. So that's, kind of the kind of stuff that you get that's been noted in the psychology literature. And so the idea was that we would try to, develop this generator, building on top of our Sparky stuff that would use some of these insights from the psychology literature to produce thousands of variants for any given text plan, and to see whether, in fact, you could get humans to perceive these things as expressing the personality that we were trying to express. When we wanted to build on these same statistical methods that we had used, kind of all the way through. So, so here's an example of some of the stuff that we can generate for, and then I'll tell you how we did it for as much time as I have. These are the average ratings from 3 judges over here. So this is the extroversion scale from introverted to extroverted here on a scale of 1 to 7. And so this is things like we put a thing in that was a disfluency generator. So it says, and we have, I'll show you a bunch of this. We produce less content. Then we have stuff like I showed you in the example that you have, like extroverts have a much greater need to talk. They produce longer utterances. And one of the ways that they do it is they repeat themselves. They paraphrase themselves while they're talking. So.
It seems to me that Lemarize isn't as bad as the others.
This is Loquendo's text-to-speech engine.
Basically, actually, I'm sure you would like Lemarize. It features friendly service and acceptable atmosphere, and it's a French, kosher and steakhouse place. Even if its price is $44, it just has really good food, nice food.
So we'd like to have a text-to-speech engine that we could, it seems like the default is more like an extrovert voice. We'd like to have a text-to-speech engine that we could do some of the introverted stuff with, on that scale. But anyway, so let me just try to tell you about how this thing works. So there had been some previous work before on kind of there's previous work on affective generation or pragmatic stylistic variation and stuff. None of this really kind of systematically builds on all this stuff out there in the psychology literature. And it's kind of completely unclear because all the work in psychology had been done on this kind of real data, like that ear data or these stream of consciousness essays or political speeches or things like that. It's unclear which of the findings of things, the linguistic reflexes of personality, would be applicable in a particular application domain and whether they would have that effect in that application domain. And there's been almost no evaluation showing that even for these more template-based or handcrafted methods of producing personality or stylistic variation, whether the variation is perceived in the way that it was intended. I already said most of this. But anyway, like I said, there's this, 50 years since psychologists have come to agree on these big 5. They're kind of like 50 years worth of psychology studies on linguistic reflexes of personality, from word choice to prosody to gesture, you know, all kinds of stuff out there. So like extroverts, they talk more, faster, louder, more repetitively, with fewer pauses and hesitations. They are less formal, more references to context, more positive emotion words. And the other thing that's challenging, though, about using this data is that they can get, because they're kind of using these big data sets, they got these significant correlations, but sometimes they're really weak, like 0.05, right? So when we started looking at this, we're thinking, okay, well, the correlations are there, but are they going to, you know, we implement that thing, is it going to have any effect on perception? So we really didn't know whether this was going to work. And the challenge was whether we could use those findings. And then the other thing that was going on here is, remember I showed you with Spot that what we were doing is we're kind of generating this normal distribution, and then we're trying to pick the stuff that's up at this end. But if you take some of our randomly generated data and you get those ratings on some of the big 5 thing, we get these normal distributions. So we have this randomized generator, just like we did before, that has all these parameters. And then we're going out and we're getting these judges' ratings, just like we did before. We're getting these normal distributions, just like we had before, only this time we're trying to train parameters that can not just pick out a few good things on this end or that end. We're trying to train parameters that can hit anything in here in the middle. So it's a really different kind of learning problem. And not only, like for a single dimension, are we trying to train stuff that can hit anything in the middle, but we're trying to hit 5 different things at the same time. So we want, you know, we want to hit agreeableness here, and then we want to hit conscientiousness down there. And so it's a lot harder, what we're trying to do. So we started off 10 minutes. Okay. So the framework is that we take these psychology findings and then we hypothesize a mapping into our generation architecture. And then we implemented those parameters on top of Sparky in the restaurant domain. So we did this big extension of Sparky. And then we've explored trying a rule-based method directly using the findings from psychology literature, like saying things like extroverts are more verbose. So we kind of try to set the parameters up there. And then we've done this thing with the random generation. And then another nice thing about using Big 5 personalities is that there are all these standard surveys out there for evaluating personalities. So we can just, to do evaluation, we just use a standard survey to do that. So this is a kind of mapping from some findings in psychology to different, those different modules. You're not supposed to be able to read this. But the basic idea is that there's kind of all this stuff. It's very vague. But we can kind of map it into these different modules of the generator, and then we can hypothesize that there's a parameter that we can implement in the generator, which is at least one way to realize that finding. And this is a different, better way to look at it. So we have the, that kind of standard architecture, and what we do is we say, okay, there's all these things that are talked about in the literature, and they affect those different modules. So this is another thing about the architecture. So we kind of break down the sentence planning into the template selection, how we do aggregation. Then we have all this new pragmatic marker insertion that are related to these personality things, like inserting hedges, tag questions, disfluencies, repetitions, all these things that are kind of really very stylistic generation. And then we have different lexical choice, which we're using WordNet and VerbOcean, and we're using some automatically. So we tried to do this really in a domain-independent way by using resources that are out there, so that for a new application domain, we should be able to do it very quickly, we would hope. And this is a kind of, these kind of generation parameter mappings, where we take these very vague findings from like ear or stream of consciousness essays, and then we propose these parameters. And these are all the parameters that we have. There's 67 of them now in Personage for doing all these different things that are all related to findings in the psychology literature. So, there's emphasizer hedges, basically actually just acknowledgments. And this is in the, we have an ACL 08 paper that has this table in it with final versions not in yet. And that's how we're generating all these different outputs, is with all those parameters being randomly varied. So I have like 5 minutes. So I won't go into too much detail about all this stuff because you already know all this. So there's all these different generation decisions for aggregation, content planning, syntactic template selection. This is done kind of automatically. We can, because we have syntactic representation, we can do stuff like like one finding might be that extroverts are more positive. So this is a template for Walkmania has awful food, and then we have a way to this one change it to be Walkmania doesn't have good food, which is kind of more positive, right? So we have all this kind of pragmatic variation that we're doing in there. For lexical choice, we can pick words that are frequent, or by word length, we look up synonyms in WordNet. We have a target, and we just look for the closest match. That's input. Yeah. So the input would be something like, okay, so it goes from, you put in, well, in the rule-based thing, that's specified actually, right? So in the rule-based thing, it would be something like extroverts use more frequent words and shorter words. So you would have a parameter in the rule-based thing, and then in the learned part, which I hope I might be able to get to, at the end, you would learn the relationship between what that value should be to try to hit a particular extroverted target. So, huh?
You have plenty of time.
Do I? You're just trying to threaten me with that 10-minute thing?
No, I think when you said you had 5 minutes left, I realized that I showed the 10 minutes too early.
Oh, okay. So we have these three generation methods. One is the rule-based, where we use the parameters suggested by the psycholinguistic findings. Then we tried over-generating rank, which doesn't work very well in this domain. Even when we use regression models for ranking, we get really high errors. And then, so we developed this new method, which we call direct generation or parameter estimation, where we try to learn directly how to generate something instead of going through the overgeneration phase. And this last stuff about the direct generation is stuff that we just finished, which is in this year's ACL paper, whereas these other results are in our ACL paper from last year. So for the original training, we had these 3 judges spend like 5 days rating these utterances for personality. So they had, it's kind of complicated, right? Because the standard psychology instruments, they don't just say, do you think this utterance is said by an extrovert or an introvert? They have these other questions which are indirectly related to introversion and extroversion that they ask, and then those get mapped. There's a standard mapping into the extroversion scale. And the shortest one of those surveys that we could find is one that's called the 10-item personality inventory, which has just two questions for each personality trait. But that still means that for every utterance that you're asking the judges to rate, they have to answer 10 questions to get their personality ratings for the utterance. Plus, we ask them whether they thought the utterance was natural or not. So for each sample, we're asking them 11 things. And so the first thing is that the rule-based personality generation, using these findings from psychology, actually work pretty well. So if this is just for introversion and extroversion, when we took the psychology findings and we tried to target introverted utterances, we get an average rating of 2.96, and for extroversion we get 5.98, and the naturalness of them is pretty high. And if you look at it this way, so this is the these yellow ones are the ones that we generated using parameters suggested by psychology literature that we thought would result in extroversion judgments. And these blue ones are the introversion ones. And if you think of this as like a binary classification problem where could we get it in the right range, we're getting like 90% accuracy. So the rule-based stuff works pretty well, but the problem with it is that we can only just do those extremes. We're not really sure how to interpolate between the extremes. And when we targeted those parameters at the extremes, you end up with a bunch of parameters that co-vary, and you don't really know which one is leading to the perception, which is the one that you're trying to get. So if you're co-varying verbosity with positive content, with repetitions, you know, even if you're varying those things a little bit, you can't tell which of those things is really having the perception. So if you really want to test the psychology findings and see whether they apply in this domain, you haven't really done it yet when you do it like that. So then we tried this, the overgenerating rank method, which we'd used before, and we actually, you know, we got results that are better than the baseline. But if you do an error analysis on these, one of the reasons why these are pretty good is all in the middle of the scale. And if you do an error analysis to what's happening with the utterances on the end of the scale, where you only had a small sample in your random distribution, the errors are really high, so you can hardly hit anything that's on the far ends of the scale. Now you could just take your rule-based method with this method, and you could have a little switch that says, when I want to generate something in the middle of the scale, I'll use this trained method, and if I want to generate stuff on the end of the scale, I'll use the rule-based method. So you can kind of fill out the whole distribution that way. And this is the kind of, you know, you learn these kind of regression trees saying, you know, like which, you can tell exactly which things you're varying and what the parameter settings are to hit different places in the scale. So this is for extroversion. So this says that, let's see, these are the high end of the scale. So it says, you know, if the verbosity is bigger than 3.5 and you use the hedge, and again, you have big verbosity, and your content polarity measure is in there. You know, you get this split like that. This is a British national corpus, so there's for any word that we want to use, we can test against the British national corpus what its frequency is. And so this is that introverts use more infrequent words. Middle ones use more concessions, right? So you can see exactly which of the features are leading to the perceptions. And so this final method, this parameter estimation, so it's kind of the same idea. You have this random set of utterances, but what we do is we generate these models that basically treat each parameter of that. I showed you had 67. Treat each parameter as being independent, which they're not, but we just treat them all as being independent, and then we just train the parameter values based on this sample with input personality trait scores. And we do a first level filtering where if a feature doesn't correlate with a personality judgment, we just kind of eliminate it. So let me just show you. And we just use everything in the Weka toolkit, to kind of learn these models. So we try linear models, regression tree models, support vector machine models, and just see which ones give us the best fit. So this is a model for the stuttering parameter, like when you should produce stuttering, and it says that if you have a conscientiousness value below 3.85 that you're trying to hit, then use linear model 1, which is down here. Or if it's greater than 3.85, then check what emotional stability value you're trying to hit. And again, so it's this set of linear models. And then it produces, it says, that stuttering, you multiply whatever input emotional stability value you put in, you decide what your stuttering parameter is going to be as a linear function of that. And so we have all these models that we trained for every parameter. So then we evaluated this with our man off the street, who happened to be, what did we say? We got it from this Sheffield volunteers list, and I think we said that they had to be master's level or higher students because we thought that undergraduates weren't, they would just do it for the money kind of thing. And we couldn't test, we wanted to design an experiment that we could tell people that they would get finished with in less than 45 minutes, or we thought we wouldn't get any subjects. So we just targeted particular combinations. So what we did was we couldn't test every possible combination of every single trait all along the whole scale. So what we did was we generated utterances to hit extremes of two combinations of traits, like conscientiousness and agreeableness, and then mid-ranges for the other ones. And that was our test set. And again, we used this 10-item personality inventory to ask people to judge them. And so one of the what this shows is that, so here's an utterance, that's supposed to hit a high extroversion and a high agreeableness, and then like in the medium range for the other ones. And for those ratings, you see that we did get something that was higher up in there, and then that's an utterance that combines those two things. And then these are the naturalness scores. One of the things that we think is that we don't have enough data, but we're still getting statistically significant differences between the perceptions, and we've been able to show that we get the perceptions that we want. And when we compare it with the rule-based, it's kind of interesting. Like I said, the rule-based method, we can just hit low or high. We can't hit across the whole scale. But so if you look at the rule-based method, the high is always higher than the high that we can hit with this learned parameters method. And I think what we have here is we still have a problem like we had with the overgenerating rank, that the original random distribution that we're generating to learn from doesn't have enough stuff in the ends, right? And I'd love to have some learning person tell me this is what you need to do to get a uniform distribution for your training instead of getting the thing that looks like that. But anyway, this is a good proof of concept that shows that it works. That we're getting, these differences between the things that we're trying to target as low and high, except for, I can't remember. I think it's, conscientiousness. That difference doesn't come out, and we don't know why. We think it might be because conscientiousness doesn't naturally show up in recommendations, but that not necessarily follow because we were able to get it to come out there. But this data is from the 3 judges who spent a whole week labeling things, and this data is from these 24 master's students. So we're not really sure about that. This is just looking at the same thing, only as correlations. So when we started off, we weren't really sure whether this would work, whether the findings from the psychology literature could be imported into an application-specific domain like that. And it looks like that worked pretty well. That even when you're asking people to make a judgment on a single utterance, they can perceive personality on that basis. And we've shown that we can generate utterances that simultaneously manifest all big 5 traits, which we weren't sure if we could do. We still don't know. We only done this for like a little limited set of speech acts, and we'd like to put this in some kind of game application or educational application or some kind of fun Second Life thing. I don't know, something to see whether it would. And it would be nice, like I said, to have a text-to-speech engine that would let us try to explore using some acoustic parameters for personality expression. And you're interested in embodiment. I think Francois could probably point at some stuff about that where you could find. So that's the, I'm done in my hour and a half, talking solidly. Yeah.
Let me preface my question by admitting that I know nothing about psychology. But that said, like I could see that you may want to understand whatever 5 personality traits that these guys have defined to analyze the color, behavior, personality, then that might influence what you do. But for generation, like if I own a call center, I would never even consider hiring anybody or designing a machine that behave neurotic, or that, some of these, I would say, what are the personality traits that I would define, maybe not the big wizards of psychology would define, would be, I want someone helpful, and I want someone sympathetic. Most of my callers are gonna be pissed off at my company's products or services. That doesn't mean that.
Service department, the sales
Right.
department's also.
Right, no, I'm saying, some of them would be like that, so those would be helpful. Maybe other traits that I could imagine would be useful, at least for a significant percentage. I doubt that anyone would be neurotic, even for the sales department, that I want to hire them.
No, but
Or-
in a
Some
gaming
gaming,
application, you might want a neurotic, right?
Yeah, but if I look at the majority of call center, interactive voice response systems today, the vast majority is customer support, maybe some sales, but and for those are the traits that I would define if I didn't read like what the big 5 are. This is what I would define, and try to see also, is there any relationship between the content and the trait? Like maybe the same person will be more upbeat, more extrovert. I'm not sure that makes much difference, perhaps for customer satisfaction. If you say, hey, you won the lottery, that's great. But if you call and say, hey, I'm so happy about your bank account is overdrawn, you only had $2,000, probably not a good thing. So maybe content would have
Yeah,
something
but if you look at the these parameters that I was talking about that co-vary, in the rule-based version. So like extroverts select positive content, they'll like focus on the bright side, and they're the ones that would have the kind of bouncy intonation kind of going along with that. So certain attributes.
Even those people, if they have bad news, they are not
We can ask
gonna
it.
be
Good
cheerful
news.
and
You should
Good news or
listen
bad
to
news
the
first?
newspaper, the CBS. These guys have the biggest dynamic range of pitch you've ever had.
Anyway, the short version to your thing is that this stuff is not really targeting call center applications, right? It's kind of saying, like the earlier stuff that I talked about, like the DARPA Communicator and the Sparky stuff, those are kind of really task-oriented dialogue. And this is kind of saying, okay, all this work in this more affective generation area is all also got the same problems as these other things do, which is it's all really handcrafted. You can't produce variation. It's hard to make stuff for new application domains. And we can do, given these methods, we can actually do something that's,
But I agree that it would be good to tailor the output to the emotional content. But I could imagine that if I were to define it, I would perhaps not use those big 5 personality traits and use helpful and maybe
helpful is agreeableness.
maybe
Trustworthy.
sympathetic, I'm sorry that you have this problem.
Those are, well, Alex, that's why I tried to show you those trait adjectives, because that's one of the things that people do is they get fixated on these top-level labels, But if you look at the cluster of trait adjectives that go underneath each label, it's kind of faceted, right? I don't have it with me, but I have this great chart that shows, like, if you just had a 2-dimensional thing between extroversion and neuroticism, and then you have these labels going all around, like which different trait adjectives. There's like 100 adjectives, right? And when you combine those 2 traits, you go from things, like moody, So an introverted neurotic, would just shut up, right? An extroverted neurotic might take it out on somebody else, right? So you get these kind of combinations. It's a lot richer than just thinking about these kind of top level goals. And you also have, with these personality models, you get a hierarchy underneath, right? So you get different things going on. But I think your basic thing is to say something like, well, for my applications, I just want 3 settings. I want.
What I'm proposing is a coordinate change. Shift this to another coordinate where the variables are the things that I care the most, which may be a linear combination or non-linear combination of those.
Yes, you
as
could
possible.
pick out, I mean, one thing is to say, well, for your application, you just want to pick out, you know, kind of 3 settings, like high agreeableness, high extroversion, and high conscientiousness, or something like that, right? Like that's a call center person. Like they're oriented towards you, they're paying attention, they're kind of trying to connect with you, and they're making sure that they do the job, right? But then for, you know, for something else, you might not, you know, if you want some kind of persuasive sales system, maybe you don't want it to be very conscientious. You want it to, you know, to,
Don't give up.
you know, ignore. So that's just trying to look at, you know, whether you can use those parameters. But I said we're not targeting call centers, really. I mean, I do think, you know, some of the stuff, like you might, if you're just designing a system, I mean, a really good interface designer will have a good sense of what kind of personality they want the system to project, and they'll write things appropriately. But that's a very expensive way to do things, is to have it be authored like that. And so the idea would we could kind of maybe get some kind of interesting variation moving away from this highly authored thing. And it might also give, even if some of this was incorporated into an authoring tool, so that you had an interface designer could see a bunch of variants, you know, and they could select and they could say, well, this is the kind of the way I want my agent to sound, so that it was a kind of human-aided design process, computer-aided design process, so where you could like see all these different variants instead of just having it be. Or you can, like with this technique, you could have, you know, maybe you'd have like 10 versions of your system. You know, like you might have one that's targeted at teenagers who want something that's, you know, more verbose and chatty, and something that's targeted to, you know, your businessman who wants, you know, telegraphic speech and short, you know, so that you know, it gives you a lot of flexibility to try to target different segments of your population that you wouldn't get some other way. If you don't, you know, you're not going to get there if you keep relying on this authoring method that everything. I know, but I'm saying, you know, that is an argument to say, well, I really only want one, you know, like my Tell Me personality, my Tell Me branded, you know, customer care agent has this personality, and that's the one we're always projecting. So why would I want anything that would generate that much variation?
You could do a machine learned personality that is better than Tell Me handling customer calls.
I don't know if Tim would argue with that, whether you can actually beat a human designer.
I don't know. I don't know.
Not on any one task, but if you have to
Do a bunch.
50,000 tasks.
Yeah, if you have to roll out 100 applications in it. That's kind of why I was asking you before, like how many applications a year, because when we were at AT&T, when they started, you know, working with solutions, they were saying, look, you know, we can't roll out, you know, 100 How May I Help Yous a year, given the technology that we've got, right? We just can't do it. So what are we going to do so that we could start to think about some kind of trajectory like that, where we've got stuff that we can, you know, generate a lot of different.
So coming back to that, like if say I have a new domain today and I want to, you know, put that sentence generator on top of it and have these knobs that you like, how much work do I have to do? Let's say this is a system that, I don't know, does front desk reception jobs. And I want it to behave one day more like extrovert, the other day maybe it's a bit moody. I want to change these parameters, but there's a task-oriented domain, right? I need to put some language in at some point.
Well, so there's two
How
questions
much, what do I
there.
have to do?
There's two questions there. So one is, I'll see you later, Ken. There's this generation dictionary, right? Which is you kind of the thing you start with, like you have a domain semantics and you have at least one way, one syntax way to say that. And in this stuff, it's handcrafted, and we've done some other work where we try to learn it for a particular application domain from like user reviews. So like in the restaurant domain, again, we did it in the restaurant domain. We took user reviews and we tried to learn the generation dictionary from that. But assume that you don't have that. You're talking about tomorrow, right? So tomorrow, you'd have to sit down and you'd have to say, well, for every kind of piece of content that this agent wants to express, I have to, by hand, make at least one dependency tree for that, or two, right? Maybe a couple different ones. And then
the knowledge about, you know, all the like word frequencies, all that stuff. So you're
okay,
saying
so
you're
the
leveraging a lot
the
of
second question is, we've trained the models for restaurant recommendations, right? So whether an extroverted concierge is the same as an extroverted receptionist, that's another question. But the other thing that you can do that I've talked to a lot of other people about is you could use the knobs. We've got 67 parameters. You could use the knobs without, see what we do, and I mean, I only kind of realized that we should also maybe have looked at doing it, you know, some other way, or it would be nice follow-on work. So we take all this variation, we pack it into 5 personality traits, then we take those 5 personality traits and we go back out to 67 parameters, we tweak those knobs, and then we're trying to say, can you recognize those as affecting that personality? And each of those knobs could be used, right? Like you could, as a designer, you know, as an interface designer, you could say, oh, I kind of like the idea that my receptionist might stutter, you know, once in a while or whatever, or, you know, and then you could just play around with that knob without going through this learning process to figure out how the knobs relate to these higher level personality trait parameters.
So I hate to interrupt, but the talk is over, so let's give a speaker a